Good morning, dear students. Welcome to Java Classroom. Today we are going to discuss about multi-threaded programming. We know that modern operating systems can execute several programs simultaneously. This ability is known as multitasking, and in system terminology we will call it as multi-threading. In multi-threading, one single program is divided into two or more sub-programs which can be implemented in parallel at the same time. So we can define multi-threading as a conceptual programming paradigm where multiple programs or called sub-programs can be implemented at the same time in parallel. Consider for example that one sub-program is executing or displaying an animation on the screen. At the same time, another sub-program can build the next animation to be displayed on the screen. So we can say multi-threading is something which is similar to dividing a task into many sub-tasks, and those tasks are assigned to different people so that they can be executed independently and simultaneously. Let us see what is a thread. A thread is something which is similar to a program which is having a single flow of control. It has a beginning, a body and an end. Let us see what is a single threaded program. So in almost all the Java programs, definitely there will be one thread. Consider for example, we have a class ABC and this is the body of the class ABC. Here you can see the code to be executed. So here we have a beginning and a sequence of statements or commands which will be executed sequentially, and there will be an end for this code. So this is an illustration of a single threaded program. So multi-threading is actually a unique property of Java which enables us to create multiple flows of control within a program. So in the case of a multi-threaded program, we know that there will be multiple flows of control, and each flow of control can be considered as a separate tiny program which is also known as a thread. And these tiny programs will be implemented at the same time in parallel. Let us consider an example of a Java program which contains 4 threads, one main thread and 3 other threads, thread A, thread B and thread C. The main thread contains the main method module, and it is actually designed to create and to start the other threads. Once the other threads, that is thread A, thread B and thread C are initiated by the main thread, they will start running in parallel and they will share the resources jointly. Since all the processes or threads run on the same processor, they share the same memory space. Actually, each thread is a subprogram of a main application program, and because of that all the threads share the same memory space, and because of this reason threads are also known as lightweight processes. So this is an illustration of a multi-threaded program. So far we have seen what is multi-threading. What is a thread? Thread is something which is having a single flow of control, and for each program there will be a single thread, and that is illustrated here. It will be having a beginning, then a set of commands to be executed sequentially and an end. In the case of a multi-threaded program, it will be having multiple flows of control. So this is an illustration of the same. There are 4 threads you can see. The main thread contains the main method module and it will be initiating all the other threads. Since they all share the same memory space, they are also known as lightweight processes. One thing you have to remember here is that when we say the threads are running in parallel, it doesn't mean that they run at the same time. Since all the threads run on a single processor, they actually share the flow of execution. And here the switching between the threads is handled by the Java interpreter in such a way that it seems to be running at the same time. Now let us see what are the differences between multi-threading and multitasking. First point is, multi-threading is a programming concept as we have already discussed. It is actually a process of dividing a program into one or more sub-programs, and these sub-programs will be implemented at the same time in parallel. And in the case of multitasking, it is actually an operating system concept where multiple programs will be executed simultaneously. And in the second point, in the case of multi-threading, it supports the execution of multiple parts of a single program simultaneously, whereas in the case of multitasking, it supports the execution of different programs simultaneously. The third point is, in multi-threading, the processor has to switch between multiple parts of a program, whereas in multitasking, the processor has to switch between different processes or programs. Okay. Then fourth point is, multi-threading is highly efficient, whereas multitasking is less efficient when compared with multi-threading. And when we consider multi-threading, the smallest unit is thread, whereas in multitasking, the smallest unit will be a program or a process. And the last point is, when we consider context switching, multi-threading will be cost effective, whereas multitasking will be expensive when we consider context switching. Next, we are going to discuss about the life cycle of a thread. During the life cycle of a thread, the thread enters many states. So these are the following states that a thread enters. First one is newborn state, then it enters the runnable state, running state, blocked state and dead state. When a thread object is created, it is born and it enters the newborn state. In this newborn state, the thread is not yet scheduled for running. At this stage, we can either schedule it for running or we can kill the thread by calling the stop function. We can schedule the thread for running by calling the start method. If the start method is called, then the thread enters the runnable state. Runnable state means the thread is ready for execution and it is waiting for the availability of the processor. In this stage, the thread will be joining the queue of threads which are ready for execution. If the threads are having equal priority, then they will be given time slots for execution in round robin fashion. Round robin is actually an operating system concept which is used for scheduling. So in round robin scheduling, actually each process will be assigned a particular time for execution, and once that time period is completed, it will be again going back to the queue of threads which are ready for execution. So if a thread wants to relinquish the control, then the thread will be calling the yield method. Either the thread can call the yield method to relinquish the control, or it can be preempted by another thread which is having a high priority. If a thread relinquishes its control by calling the yield method, then it will be going to the end of all the runnable threads. From the runnable state, the thread will be entering the running state. In the running state, the processor has given its time for the thread for execution. Either the thread will be preempted by a high priority thread, or it can relinquish the control by calling the yield method. There are three situations under which the thread can be in a blocked state. The first condition is that if the thread is blocked by calling the suspend method, then the thread will be entering the suspended state or in the blocked state. If the suspend method is called, a running thread will be entering the blocked state and the thread will be suspended. So as you can see here, from the running state, it can enter the blocked state by three methods: suspend, wait and sleep. If the suspend method is called, then we can revive that suspended thread with the help of resume method. If wait method is called, then also the thread will be entering the blocked state. That is, if the thread is called with the wait method, then the thread will be waiting for a certain amount of time until a particular event occurs. And such a thread can be again scheduled for running with the help of notify method. So that is also illustrated over here. A running thread, when called the wait method, will be a suspended thread, and this suspended thread can be again made runnable with the help of this notify method. And the third situation in which the thread enters the blocked state is by calling the sleep method. So the general format of sleep method is sleep of t, where t denotes the time in milliseconds, which means if you give sleep of 1000, then the thread will be then in a state of blocked state. Thread will be in a blocked state, that is, the thread will not be in the queue for 1000 milliseconds. So that's all about running state. And a thread is said to be an idle thread, or it is in a blocked state when it is prevented from entering the runnable state, subsequently the running state. So as you can see, from the newborn state, from the runnable state or the running state also, and from the block state also, we can call the stop method so that the thread will be killed. So we know that every thread will be having a life cycle. When it completes its execution, then automatically the thread will be killed, and in that case it is a natural death. But if we call the stop method, then we can kill the thread before its death, and in that case it is a premature death. So this is all about the life cycle of a thread. There are totally 5 states: newborn state, runnable state, running state, blocked state and dead state. A new thread will be in the newborn state initially, and then it enters the runnable state, which means it is ready for execution. From the runnable state, it will be entering the running state where it is allotted time for execution. And by calling the suspend, wait or sleep method, the thread will be entering the blocked state. And if the stop method is called, that will result in the premature death of the thread. Now let us see how to create a thread using the thread class. Basically, there are 2 ways to create a thread. First method is by extending the thread class, and second is by implementing the runnable interface. So if we are going to create a thread using the thread class, first of all you have to import the package lang, java.lang package, because the thread class is defined in the lang package. Then the first step in creating a thread using thread class is that first you have to declare the class as extending the thread class. So in this example, I am taking the name of the class as my thread, and it extends the thread class which is defined in the lang package, and this will be the body of the class. In the second step, you have to implement the run method. We know that the run method is the heart and soul of a thread. The thread's behavior can be implemented only with the help of a run method. So that is given over here. The general format for writing the run method is public void run. Then within the opening and closing brace you have to specify the code to implement the thread. And once you have implemented the run method, you have to start the thread. So in order to start the thread, first you have to create the object of the class. So here I am creating the object a thread. This is my class and this is my object. My thread, a thread is equal to new my thread. So here I have created the class, and after that I have to call the start method with the help of the object I have created, that is a thread dot start. So this statement will start the execution of the thread. So with this we have come to the end of this session. Thank you.